All right, ladies and gentlemen, today's information is really just a continuation of last Friday's information as well, really our day 2 of graphing linear inequalities. So I'll do a few with you just to kind of remind you and also show you 2 that some students tend to struggle with. All right, we're on number 4. If you notice, it is ready to graph because I can think about it as, actually, sorry, before I do that, I'd like to label that it is a dashed line. So I'm going to go ahead and think about it as y is equal to negative 2/5 x add 2. So this tells me again that my slope is a negative 2/5, which would be a downhill line, and my y-intercept is a 0, 2, which is the point on the y-axis. So now that I have that information again, I'm going to go ahead and plot my starting point, which is my y-intercept at 0, 2. And then according to my slope again, I'm going to count down to right 5. Down 1, 2, right 5. If you notice, I run out of room. So again, this is our backwards thinking. Up 1, 2, left 5. Due to it being a dashed line, go ahead and line up your straight edge and connect it. Let's see if I can do... Nope. So line it up the best you can with a dashed line. And then again, we're thinking about this origin. Just for our demonstration purposes, I'm going to go ahead and put a highlighter dot there and say that, of course, is the origin, and that's what we're going to be testing. Normally, we don't put a little dot there because students may think it's part of the actual graph, but again, that's just for identification purpose. All right, so back to our original problem, I'm going to say 0 is less than negative 2 times 0 is 0, plus 2, 0 plus 2 is 2. So it's going to say 0 is less than 2, which of course is a true statement. So that means I shade the side with the origin. So we're doing line segment shading, and we're going essentially to the end of our boxes. And then, of course, putting the original problem, y is less than negative 2/5 x, add 2. Now, the reason I like these problems, again, is they are ready to graph right away. Solid or dashed, the more we practice, we won't make those mistakes anymore. Again, it's really just practicing your slope and y-intercept. Testing your origin, again, kind of that testing out, trying on the shoes analogy that I gave you last week, will help us determine what side to shade. If it's true, that means you like those shoes, so you will stay with that. If it was false, I would have gone to the other side. All right, so let's look at 6. This is still a coordinate plane graph. So it's not a number line graph, even though there's only one variable. There's a few ways we can think about this. Before I start it, I'm going to say it is solid. I'm going to say y is equal to negative 2. So there's a few ways you can do this. The previous way that I taught you all the way back in chapter 2 was just trying to kind of a guessing game. Now that we are officially doing our graphing, we're going to look closer to our t-chart. T-chart, again, is just a way of organizing your information, and it says y has to be negative 2 because y equals negative 2, which tells me that my y is negative 2 for every single point. It doesn't matter if you stop at 3 or go all the way to 10 points, every single y has to be negative 2. For your x's, it can be a variety of things. The easiest way for students to remember is simply counting 1, 2, 3, because any point would work as long as the y is negative 2. So when I put my 3 points, I'm going to start at my origin and just do my directional counting. X is 1, y is negative 2. Back to the origin, x is 2, y is negative 2. Back to the origin, x is 3, y is negative 2. So I could have gone to the left for my x's, so x is negative 5, y is negative 2. Every single y has to be negative 2. The reason that students get confused on this is sometimes they accidentally see this negative 2, which is really the x, And they say every point has the -2, but that's really every x is -2, and we want y is -2. All right, so let's go ahead and connect it to make a solid line. And it gives us a horizontal line. Highlighter demonstration purposes only. Going to focus on the origin. And I'm going to test the origin. This says 0 is greater than or equal to -2. Is that true or false? That is obviously true, because 0 is greater than any negative, so that means, again, I'm going to shade the side with the origin. I like that pair of shoes. So again, just make it go up. Again, this type of shading will make more sense next week when we are doing it for 2 lines instead of just 1 line. And then again, I'm going to label it y is greater than or equal to -2. So number 5 is somewhat similar to what we just did there, where it's a y, but we're going to go ahead and look at number 8 now, where we have an x. Now, the reason I'm reminding you that it's a coordinate plane is because that's actually very similar looking to when we did it on a number line. But we're on a coordinate plane today. So, solid again. Let's see. Equal sign. T-chart. It tells me all my x's are 5. X has to be 5. Well, if x has to be 5, I make it so. X's are 5. So if I know the x's are 5, what does my y have to be? Yeah, anything I want. So I'm going to say 1, 2, 3. That's the easiest for me. So what I'm going to do again, my directional counting, starting at the origin every time. X is 5, y is 1. Back to the origin. X is 5, y is 2. X is 5, y is 3. I could have done x is 5, y is -3. As long as the x is 5, I am good. All right, we got a solid line. And for demonstration purposes, let's put a little highlighter dot there. I'm testing the origin. When can we not test the origin again? Yes, when the line is already touching the origin. It's kind of like you already own that pair of shoes. All right, so looking at the original problem, I'm going to test 0, 0, which I really just need 0 is greater than or equal to 5, because I'm really just interested in the x. So 0 is greater than or equal to 5. That is a false statement, which means we do not like that origin. So we're going to shade this way, the other side. And quick label, x is greater than or equal to 5. Beautiful, very nice. All right, looking at number 10. Well, number 10, we have another solid line. And I have x subtract 5y is equal to -5. If you notice, it's not ready for graphing because it's not y equals. So I'm going to bring it over here to the right where I actually have some room to work. And I'm going to do the 2 steps again. Move the x, then divide. So if I subtract 1x on both sides, that gives me a -5y is equal to a -1x, and then a subtract 5. Divide everything by -5. Again, those 2 basic movements, we've done that very long time this year. So y is equal to, a negative divided by negative is positive, and I've got 1/5 x. Negative divided by negative is a positive, positive 1. So my slope is 1/5, which means it's a positive slope going uphill, and my y-intercept is 0, 1. So again, finding my starting point, which is 0, 1 on the y-axis, it tells me up 1, right 5. Ran out of room, so backwards counting. Down 1, left 5. Make your solid line, please, and then we will test the origin. All right, highlight our purpose here to check and test the origin. All right, back to the original problem for the test. 0 subtract 5 times 0. Haha, so 0 is less than or equal to negative 5. What do you think? 0 is less than, and again, it's 0 because 5 times 0 is 0. 0 subtract 0 is just 0. That's why we love the origin. 0 is less than or equal to negative 5. False. Which means I do not like the origin. I'm going to go to the other side again. What I'm creating here again is called the area of solution. So every single point in that shading would be a true statement. So if I didn't want to test 0, 0, I could test anything in here. Since the line is solid, every point on the line is also a true statement. It would satisfy the condition. All right, quick labeling. X subtract 5y is less than or equal to negative 5. There we go. All right, one more. Again, the question was previously, when are you not allowed to test the origin? And our response was, well, when the line already touches the origin. So if you notice number 11 and we're going to do 14 together. It's got that 0 to the right of it. And that's kind of a heads up that your y-intercept is going to be 0 already, which means the origin is part of your line, which means you technically cannot test the origin. So let's do that together. So 14 one more time is solid. Without the equal part, remember, it would be dashed, just like number 12. So I've got 3x plus 2y equals 0. It's not ready for me to graph, so I'm going to do my 2 steps again, move the x, then divide. So I'm going to subtract 3x on both sides. Gives me 2y is equal to just a negative 3x. There's no point in putting a plus 0 there. Divide by 2. So y is equal to negative 3 over 2x, which means it's a negative slope, so it's going downhill. It will be pretty steep because we see that it's an improper fraction. My origin is my y-intercept, 0, 0. So when I start it, it's starting at the origin, so I'm going to have to test something else. Again, down 3, down 1, 2, 3, right 1, 2. Looks like I have enough room. Down 1, 2, 3, right 1, 2. I could also go backwards. Up 1, 2, 3, left 2. Up 1, 2, 3, left 2. All right, so zooming in again, we cannot test the origin. See how the origin is already on the line. So we want to test something else. Remember, great suggestion would be 1, 1. If 1, 1 was on the line, you could not test 1, 1. Maybe 2, 2. Well, if that doesn't work, find something else. But 0, 0 is the best. 1, 1 is a great alternative. I really like it when the numbers are the same so that when you come over here, it's really easy mental math. The origin would be 3 times 0, 2 times 0. 1, 1 is 3 times 1 is 3. 2 times 1 is 2. 3 plus 2 is just a 5. 5 is greater than or equal to 0. Now again, I'm testing 1, 1. It's kind of like that different pair of shoes. 5 is greater than or equal to 0. Obviously a true statement. So that means in reference to this highlighted point, the 1, 1, I like that. So I'm going to go ahead and shade that side. If I did not like it again, I would shade the other side. Again, just nice line segment shading. Quick label. 3x plus 2y greater than or equal to 0. All right, so great practice for what we're going to be doing next week. So on the 6th, we are continuing with our testing. If everything goes as planned, we'll be back in here on the 7th, graphing 2 lines instead of 1 line. We have a quiz on the 10th with these exact skills. You can do it. All right, so work on completing the remaining problems and be awesome.